everyone. I'm Heather Cumberworth-Lane. I'm a platform engineer at Education Payroll. It's the company that was created to take over NovoPay.
Yeah, and again, my name is Everett Taves. I'm Taves on all of the things. I'm also a platform engineer. I actually work with Deloitte and Education Payroll Limited, or EPL, as we'll probably throw out a couple times at least, is kind of my primary client, and I've been working with them for well over a year now. And we actually have the privilege, the honor and the privilege of having our product owner here in the audience with us. Okay, so GitOps, what is GitOps? Like for a really broad definition, I term it as like just applying the Git workflow to operations. So developers have worked with Git, for a long time now, and then they've worked with all sorts of version control systems, since forever, right? And Git is the distributed VCS that won out effectively. And so we can kind of take some of the things that developers have been doing all this time, and we can actually apply that to operations as well. But said another way, I also consider it applying a developer experience to operations, because like what's more developer centric than just working with Git day in, day out, all day, every day, right? So we can take some of those ideas that we've been using as developers and operations people a lot too, and start applying that to one particular use case that we did at EPL, and that's using GitOps or using Git and interacting with Git in order to drive deployments.
So while we start to look at this GitOps-driven deployment, we're going to start at the end. We're going to propose a new version be deployed via pull request. A webhook is going to fire when this is merged in, and then a new version of our application code is going to roll out. Now, because I didn't make a sacrifice to the demo gods, we have a video, because demos are dangerous. What we're seeing here is our main pipeline. This pipeline kicks off other pipelines. And this deploys our application stack, which is commonly called EdPay. What we have here are service pipelines, and we'll see these get kicked off in a minute, one for each part of our stack. Our current stack is made up of 3 applications, or containers in this case. So over here in Bitbucket, which is our source code repository, we have a number of environment repos. We have a lot of environments. This is old. We have more now. This dev build master environment is where all our builds happen, and this repo contains 2 files, version and service properties, but Everett will get into those a bit later. What we have here is a pull request. I'm sure all of you who are familiar with Git have merged in more than a few of these. So what we're going to do here is we're going to merge in a pull request. This one here proposes a new versions of our applications. So this one's been merged in, and a webhook is fired, and it has started our pipeline. This master pipeline here, or environment pipeline, it kicks off all our other pipelines, the ones that build and deploy the services. So the first step there was to clone some configuration and now deploy the first part of our stack, which is our identity server. This service pipeline here reads some configuration, builds and tags our container, and deploys it. And the environment pipeline verifies the deployment is what we intended to deploy. Now we have the second part of our application stack starting. That's this EdPay services, which is our APIs, checking out the code, building and tagging and deploying. And now once again, we've gone back up to the environment pipeline to verify the deployment. Once that's verified, it is the version that we asked for. It moves on to the final part, which is our UI, which is currently an Angular UI. And that will run the same service pipeline, same steps, except this one includes linting. Builds, tags, and deploys. And what we're seeing here is a complete deployment of an entire application stack for us.
And a lot of the versions aren't even changing here, so that's actually why it's happening quite so quickly.
Yeah, it's about 40 seconds if it's a completely new version. So we have a clean pipeline run here for each part of our stack. We have 2 pods for each part of our service running here in our overview. Next, we're going to zoom out a little bit, and we're going to look at the hardware and the application stack that all this is running on. So this is our world. We have our UI, which runs in the browser. We have API Gateway, which is currently running on Azure. We have an on-prem installation of OpenShift, and this is where the pods run, the UI, the APIs, and the identity server. And this currently runs on-prem because of the monolithic database, which I like to think of as Cthulhu lurking beneath. If we chose to run this on the cloud, then there would probably be about 10-second delay on every API call, and nobody wants that.
And if you're familiar with the NovoPay debacle, that's it right there.
But he just looks so cute. Yeah.
Had to be put to sleep.
Next, we're going to look at flow. And for these GitOps deployments, we have users or environment owners in this case. We've got Git pipelines, which for us are Jenkins pipelines. Jenkins is our CI/CD server currently, and the environments themselves. Now, this is the flow. This is not meant to be read or understood because it's a lot. We're going to break it down bit by bit as we go through the various parts of our flow.
Okay, so first up is Git, which is what our users primarily interact with. And like, if you're here sitting in this room, I'm going to go ahead and assume that you know what Git is, so I'm not going to get into it. Yeah, let's just get on with it. Sorry, I did not plan these puns. My bad. Okay, so up in the top left of the sequence diagram is kind of where the users start interacting with the system, and that's just via the Bitbucket GUI. In most cases, that's where they propose their version changes or configuration changes for an environment. And so they go in and make their change, and when the commit is merged, that's what kicks off the pipeline. Or you can actually go in and you can start the pipeline manually as well, but this is all automated in this case. So some of the stuff we get from Git is everything that we've kind of taken for granted as developers and operators for the longest time, right? You get all sorts of access control around your repositories, who can merge and who can't merge, and what they can even see, if they can see a repository at all. All the auditability around just having a Git commit history. Like, this is remarkable stuff for a lot of people outside the world of DevOps, right? And in Git, we have all of our environment repositories that we saw in the video there, and I'll go into a bit of detail. And then our service repositories, which is really just our application source code repos. So this is an early screenshot from the number of repositories we have for our environments. So like, being able to create environments on demand, within OpenShift is really a double-edged blade, right? Because the EPL is kind of addicted to their environments, and they love to kick one up for the flimsiest of reasons, and we've just had kind of trouble saying no. We got to get better at saying no, or at least cleaning up some of the environments that they don't use. But anyway, we have a repo per environment. Now, what's in these actual repos? There's simply two files, a service.properties and a version.properties, and this is the config that's sucked in by the pipeline when it's running. So in the service.properties file is basically all of the configuration that makes up an environment. So these are all of the things that vary from environment to environment. And kind of the primary thing is the database that it's connecting to. There's different versions of the database per environment. And then the version.properties is even simpler. And the fact that these files are even broken out as two different things is just something that we did to make it easier for the people who are using this thing to understand. They typically only ever go and change this one file to the version of the services that they want running in a particular environment. And so, of course, the other thing that we get from Git is a webhook. So we take the webhook URL that we want from OpenShift. This is like the target, effectively, and we go ahead and we paste that into Bitbucket. It's a bit of a manual step, but that's okay. We only ever do it once when we create an environment. And here are the service repositories, and like I said, they're just your vanilla source code repositories. These services are written in C#, so they're laid out in kind of the standard C# source code format. And We do actually have, on the bottom there in the README, we mentioned that we've actually put some of the artifacts, some of the manifest files for OpenShift, like the deployment config, which is like a deployment in Kubernetes, and the config map for a particular service within its own repo. So it is versioned alongside the source code that makes up the application itself. So the deployment is versioned alongside the application source code. And then, of course, there's our commit history, and this is typically where people go to version a particular what they want to roll out for a service. They just go in, usually through the GUI, click on a commit that they say, okay, this is a version that we're interested in actually deploying out and starting to move through the different environments, the software development lifecycle environments. And it's just a simple matter of clicking into a field and punching in a semantic version. And we go ahead, and that is the version that goes into that version.properties file. So that's how the pipeline knows what commit to build as it's going through its business of deploying, building, tagging, and deploying out the service.
So the next part of our GitOps workflow is pipelines. They take the things and put them where we want them to be. I like to think of it as the cardiovascular system of our OpenShift deployment. Our environment pipelines, these invoke the service pipelines, as we saw in the videos, and these environment pipelines, they also verify our deployments. They also apply all configuration from templates, from the app settings files that for each individual service, and the templated deployment configs themselves. So this environment pipeline is this part of our slightly overwhelming sequence diagram. And it corresponds with this pipeline from the video, the one that triggers the service pipelines and verifies deployments. Our service pipelines, they check out the source code from the service repos. These build the images, and they also invoke builds and deployments. And this, as Everett likes to say, is the only piece of code that we have in our presentation. It is probably the most important piece of code for our GitOps-driven deployments. This processes our deployment template, applies the version, and then applies it to a project. And this is what triggers our rolling deployments. Our service pipelines correspond with these two highlighted parts of the sequence diagram. These are triggered by the environment pipelines and correspond with those pipelines there from our Dev3 master, which is our build environment. Now, our builds, of course, are immutable. Unlike traditional ways of deploying, you build once in our dev environment, and then you build that up through the various environments or higher environments just by applying your service properties config that makes one environment different from another. Our builds are source to image, which is a big step up from Docker for us. It made all our build images about a third of the size. And here are our builds in OpenShift, one for each part of our component stack.
Yeah, so now we get to the environments and the last part of our flow throughout the system. And really, like I kind of mentioned before when I was talking about the repos, the environment repos, it's really, you can kind of sum up environments as just a combination of the services that are running within that environment, which is just a namespace in Kubernetes or project in OpenShift, and the configuration for that environment, which is the service.properties and version.properties files. And so, you can kind of sum it up in the overview screen here that shows the various components running that make up the whole application stack, and we got a couple pods per. It's relatively low scale, but we can actually handle quite a fair number of users. And to that point on performance testing below from Vanessa, which I thought was excellent, we too have had a performance tester with us right from the start. And like early on, we're just like, man, just give us some space to breathe here. Like we know the thing's not performant yet, but I'm ultimately really glad that he was with us every step of the way, tracing the performance. So we had a good baseline, and that we know that we're never kind of stepping out of line when it comes to performance.
Yeah, we never needed a chaos monkey or a chaos cube. We had a chaos Murray.
Yeah, chaos
Murray.
Murray.
Would hammer things until they died.
Yeah, and he's pretty good at it, really. And then so we just have a config maps, relatively simple configuration for the services, one per service, and it's actually just a template that gets that we suck in the configuration from that service.properties and apply that to a config map template, and that gets fed into the running service deployment. And of course, we're using secrets as well, and naturally, we're not going to show you any of those. Okay, so this whole time, we've actually been talking about one particular type of environment in that great big sequence diagram, and that's our build dev environment. So this is the environment where we actually build and deploy services, and we only really have two of these environments, what we call master and stable. And master is maybe a bit of a misnomer. What we're doing there is deploying the head commit of the master branch into that environment. So like on demand, we can get an integration of all the services in that particular environment. And so that's like the bubbling cauldron of source code where anything goes, basically. It could be broken, maybe it's working, maybe it's not, doesn't matter. It's just a place to get an early integration and see if there's something that is immediately and apparently wrong with something between the different services. And then stable is the build dev environment where we first do the versioning. That's the environment where any one of the components can, first get a version that, we think might actually be deployable and deliverable out to end users ultimately. Okay, so boom, that's the whole thing there. Again, not intended to be consumed, as you're sitting in your seat there, but that's the whole thing. That's our build dev environment. So the other type of environment we have, and there's really only two, is higher environments. There's the place where we build all of our container images, and then there's the other environments where we deploy them out, and we consider these our higher environments. So there are test environments, demo environments, lab environments, pre-prod environments. What am I missing? Performance testing environments. Staging, yeah. Beta, and then finally prod. So like I said, EPL is kind of addicted to their environments, and unfortunately we're an enabler of that addiction, which is, anyway. Okay, so, but the thing I want to point out here is that like prod is just another environment. It's the same as any of the other higher environments. And when it comes to this stuff, I'm always hammering on about fidelity between the different environments, because every time you have a difference between your environments, that will cause an outage or a deployment problem, I guarantee it. So the only difference here is that, well, it's actually a whole different cluster, which you might think is kind of a big difference, but ultimately, it's not, because really all we have to do is copy over that container image for each one of the services over to the prod cluster, and we then run the rest of the pipeline as we would in any other higher environment, exactly the same. But of course, the prod cluster has much more restricted access. And that's the sequence diagram for the higher environment. Super simple, just deploy everything and verify it. And then there's actually a smoke testing step at the end where we create a little headless Chrome browser and actually do some smoke testing steps. So some of the benefits around GitOps.
Yeah, so this is all great, but why did we do it and what does it give us? As you saw, we have a lot of environments and there's more every day. So this gives us consistency via versioning. Every time we deploy something, the deployment templates that sit alongside the services, we know that when we deploy version 6, we get version 6 of all the deployment templates. And we know that we get that all the way from dev to production. This removes a lot of margin for error when you have such a high change environment. This also gives us the ability to give all of our teams or environment owners self-service. When you have this many teams and this many environments, you don't want them coming to us to do all their deployments or configure their environments. So this gives them the ability to do that themselves. This also gives a lot of flexibility when various teams move between environments or projects. This also gives us a really great way of breaking down the wall of confusion. When I first started at EPL, deployments were zip files. It was not a good time. And sometimes they would work, and sometimes they wouldn't, and sometimes somebody would get a phone call at some awful time in the morning. With this type of deployment, we know that if it deploys to dev, it's going to deploy to production. And this means that some poor person doesn't get woken up at some terrible time in the morning.
Do you want to tell the auditor story?
Oh, yeah, we had an auditor come in recently. It was quite short notice, a little bit unexpected, but he sat down with us. And it was literally checkbox after checkbox after checkbox, because everything is in Git and it's versioned, including our documentation. So this was a big win for us because we weren't expecting it to go that smoothly.
Yeah, and we've actually gone through several rounds of auditing, and it's always been a really positive result. They're kind of floored by some of the stuff that they've seen, and give me screenshots, give me screenshots. Yeah, we can do that. Okay, so what are kind of some of the other other systems that are related to something like this? Turns out Jenkins X is doing something fairly similar, and that was a project that was kind of it was kind of nascent when we started building this thing out. So it wasn't like immediately adoptable, but it does things in kind of a very similar fashion, and actually maybe takes it even a step further with like creating environments for a pull request and stuff like that, which I think is really cool and worth a look. Weaveworks has their Flux project, which was recently donated to the CNCF and is in the sandbox there. And Weaveworks is definitely credited with kind of bringing this notion of GitOps to the forefront and kind of coming up with the term. And they've done a great job of advocating for it, and I've been a big fan. And then this last one here, kind of unrelated to deployments. Oh, actually, the other thing I want to say about Flux is that, and Jenkins X. Jenkins X is a similar push model to what we're doing with this system, whereas Flux is a pull model. It's actually more of an operator running in like a Kubernetes cluster and looking for new images to deploy and sucking those into the system rather than those images being pushed into the system. So different model and both definitely worthwhile and worth a look. And then this last one is just around actually kind of making, a more general look at GitOps and like, being able to drive other stuff like doing your DNS with GitOps and stuff like that, which I think is a brilliant approach to this stuff. Put your desired state in Git and let systems resolve that state and make sure that you're in your desired state. So that brings us to the end of our presentation here. Kind of the big takeaways are, all those benefits that we mentioned around, using GitOps as a technique and all the out-of-the-box stuff you get from Git. Was there anything you want to add?
No, just reliability, consistency. They're big things for us as we move from dev to operations.
Yeah, huge. Okay, thanks so much. Questions? Bruno.
You were talking about fidelity across environments and multiple environments, but also that monolithic database. So how are you guys getting a database or something that looks like it across all your environments with data that actually has some fidelity?
Many databases.
Yeah, and what they do is they do that thing. Oh, yeah, so the question was, how are you getting fidelity with your monolithic database? And Heather's answer there too. And then what they do is they'll take kind of snapshots of the database, and they'll start refreshing all the different databases, kind of back through the database environments. And that is not a solved problem because occasionally, maybe a little too frequently, they'll do a refresh of a database and like things go totally haywire. And everyone's like, sometimes it's a surprise that the refresh even happened. Like, oh, hey, can you give us a heads up next time? So that sort of thing is still going on at that database layer. But the processes are improving around that stuff too. And we've got a new release train engineer kind of helping us work through some of that stuff. But yeah, good question.
How do you manage secrets? Like, is it part of the pipeline process?
Yeah, how do you manage secrets is the question. Yeah, so kind of it's a bit out of band actually. We have our secrets in Git, and before you pull out your weapons and start shooting, it's actually encrypted with Ansible Vault and then put into Git, and then we have a password that really only the two of us know. Oh, and I guess Mike, you too. No, Mike doesn't even know that password. And then we have a little bit of Ansible that we run that when we need to rotate a secret, we'll make the updates with Ansible Vault Edit, and then it also runs some stuff to actually restart the services, redeploy the services automatically, so it'll pick up those changes to the secret. Yeah.
So one more question. Does the pipeline will have like the secret to decrypt the secrets actually? So how does encryption and decryption of the secret happens at the runtime?
No, so the pipelines don't apply secrets. It's done beforehand just using Ansible.
And we do have a handful of secrets in Jenkins using the Jenkins credential manager thing.
Yeah.
One more. Have teams been asking for dynamic environments? They created an environment per branch?
So yeah, they have been, but we're restricted by the databases currently. So it would be great, given our large number of projects, if we could spin them up and down as required. But it's coming.
Okay, that's it. Thank you very much.
Thank you.
Thanks.